Hello everybody and welcome to episode 5 of our Custom System Builder short series. As promised, today we're going to go over formula. Don't worry, I plan to start as simple as possible and build our way up through increasing difficulty. However, this topic is a little bit more complicated than what we're used to, so this episode is going to be a little bit different. We're going to go over introducing the topics now, and there's going to be a second episode, episode 5.5, where I work on automating parts of the sheet and showing you how those concepts are actually applied. That being said, I'm going to work to make sure in this episode things are still kept grounded and practical. With that all in mind, let's go ahead and open our showcase actor. I'm going to start by creating a label beside our checkbox that just says I'm on. While not entirely necessary, I'm going to go ahead and reload our actor just to show it's there and works as expected, just for your benefit. Now that we see our component exactly as expected, let's go ahead and start with visibility formula. You can access visibility formula in the advanced configuration section. And I want to start here because the extra icon's right beside the field. In order, from left to right, they're the $, the crossed out curly brackets, and an info button. The $sign means that this field can accept formula and we're not limited to plain text input. We'll get into what that means in just a second. The crossed out braces mean that we don't actually have to use CSB special notation when we're doing our formula, and again, we'll see what that means in just a little bit. If we hover over the I, it'll tell us that this component is visible when the content resolves to be true. Building off of that, let's enter true into our label's visibility formula, save, and refresh. You'll notice that nothing changed. That's because components are already visible by default. So let's go ahead and go back and enter false. Now our component is gone. Keep in mind that 1 and 0 will do the same as true and false. Okay, well, a checkbox is either on or off and returns true or false, right? So let's go ahead and reference our checkbox here. Thankfully, we don't have to do a lot to make that happen, so we can just go ahead and put our checkbox component key into our visibility formula, and there we have it. Our component is now only visible when the checkbox is enabled. We have a lot of power using visibility formula to sweep ugly backend components under the rug, conditionally hide parts of our character sheet, and so much more. But why does entering our component key name into the visibility formula make this work? Shouldn't that just be a string that contains the characters T, S, and T? And if so, since that string has content, shouldn't it always be true? That's where the crossed out curly braces icon comes into play. If this symbol is present, then the text within resolves as a formula and not a string automatically. Let's go ahead and get a better idea of what's actually happening by removing the visibility formula from our component and putting TST into our label text field. If we were to just save this component now, it would just be the text TST. And that's because the label text input field doesn't actually have the crossed out curly braces icon, so we need to tell it that this is code and not text. We can let CSB know to treat this as code by surrounding our code area in a $, curly brace combination, which acts like opening and closing a parentheses, marking the area within as a code block. That being said, everything outside of our code block will just work like plain text, so we can use this in conjunction. Let's go ahead and see what happens if we just put TST inside of our code block. As you can see, only the middle TST, the one that was encased in our code block, is going to change to true or false, which is why our visibility statement, which was just TST, was resolving to true or false. Calling a component inside of our code block is just shorthand for using the reference or ref function. In fact, there's a whole list of functions available to us on the wiki, and we'll be seeing a lot of those throughout the series. In addition to what's listed under the function section on the wiki, if we go to the Formula System tab, scroll down, we'll see common functions from the Math.js library, which we have access to inside of Custom System Builder. Math.js will give us the additional tools needed to evaluate or manipulate our values. For example, we can check if text is equal, append values, as in string them along to the end of, round our numbers, check what number is greater, or do arithmetic. And don't worry if that's overwhelming for now. We're not going to worry about everything out there, and we're just going to focus on the components that we've already covered to get a basic idea of what's going on behind the scenes. As you can see in our next panel, I went ahead and made a radio button that's in the on-off radio group. You may notice that you can't see the second button on the template, and that's just a bug with Custom System Builder version 5, but it is there. I could turn on light mode to show you, but I'm not going to burn our eyes out. Just trust me for now. What happens if I call test2, the name of our first radio button component, inside of our code block? Well, our button is always returning on, which is test2's value. The same would be true if I called test2 underscore copy1, the name of our second button. It would always return its value of off. So what if I want to return the value of which one is selected? We can go ahead and enter the Radiobuttons group name inside of our code block, and that will return the value of our selected button. In our next panel, we have more Radiobuttons in another group. And what we just covered still applies to them. If we call the Radiobuttons group into a label, we'll get back the value of the selected option. So if in our system we need to return the selected rarity, we can do that quite easily. You're probably already picking up on a pattern here. Calling a component's name, or in the case of a radio button, the component's group, will return its value. What do you think will happen if I call a label's component key as a reference? If you'd guessed it would return the label's text field, you'd be right. Up next are dropdowns. Go ahead and take a guess what calling the dropdown's component key will return. It returns the selected option. So the reason we didn't have to call its group is that it's one component, unlike radio buttons, and it doesn't actually have a group. So it's implied that we want the selected value. As we covered in a previous episode, dropdowns have keys and labels for other options, where labels are just human-readable text that have no actual impact. So when we call the dropdown as a reference, we'll always get its selected key. What if we want to make a proficiency system where we return the modifier when the dropdown is called, but later we want to return the label instead? Unfortunately, there's no native way to do that, but we can absolutely make that happen with one of our functions. Let's go ahead and take a look at the switchCase function. Switch cases are a lot like rigid if statements, where we know that our input is going to be one of these selected values. So let's go ahead and update our dropdown to have numbers as our proficiency key, then narrative labels for our players to read. Now our reference will return a number like -5. Instead of using the reference function, let's go ahead and empty our label and open a new code block. And inside the code block, let's go ahead and type switchCase with open and close parentheses. I always like to use the examples from the wiki to get a good idea of how a function is going to work and what arguments it's expecting. So let's go ahead and look at how it's used. So as we can see here, we enter the dropdown key in the parentheses, and then the first input that we might expect, and then what we want to return when that case is true. If we look closely, we can also see that any kind of text needs to be surrounded in quotes unless it's a component key or something that we're referencing. Let's go ahead and try that in our dropdown. Before we save this, let's go ahead and just add a little bit of complexity by adding parentheses outside of our code block, which is just text and not actually doing anything. But let's go ahead and open another code block inside them and call our dropdown key in there. Save and refresh. Now our output is the dropdown's label and then the key in parentheses. As you might have just noticed, my journeyman caused an error when I called 0 without the single quotes around it. I think that might be because 0 is not being counted as a number in this case. You might also have noticed that I called all my negative and positive numbers inside of single quotes, and that's because adding the negative sign or the positive sign is making them act as strings rather than numbers. Text fields and number fields work just like you might expect. If I reference the component key, I get the contents. Same thing with the labels. Now we've covered what you'll get when you call different values in Custom System Builder and how to get the values that we actually want with different components, as well as how to use the functions on the wiki. I'll go ahead and introduce 2 more concepts before moving on to applying this all to our sheet. Don't worry that we didn't cover all the functions on the wiki. That's always there for you as a resource, and we'll be seeing a lot of them in the next episode. In our number field panel, I've created 2 labels, both with the text TBD. I'm just using that as a placeholder for now since I'm going to be building something in each of these. Let's go ahead and say this number field is equal to our health, so we went ahead and give it a prefix for HP. I want to go ahead and return the player's condition based on how high their health is. While I could use a switch case, I'd have to make a case for each number in the range, and since our health is going to be measured from 0 to 100 in this case, that would be 100 cases to enter. And frankly, I'm just not going to do that, and nor should you. So let's go ahead and learn about if statements. If statements are covered in the wiki just below the common Math.js functions if you wanted some more examples. But it follows a simple format of the thing that we want to evaluate, also known as the condition, followed by a question mark, since we're questioning whether or not that's true. and what happens if that resolves to true, followed by what happens if that resolves by false, separated by a colon. Basically, if this thing is true, do this, else do that. Let's go ahead and see that in action with our number field. If our current HP is less than 10, our conditional is critical. And I'll go ahead and put single quotes around this since it's a string and not referencing anything. In our else statement, let's just go ahead and leave an empty string, marked by 2 quotation marks, which goes ahead and tells the system just do nothing, send back an empty string. Now I could do 3 if statements in a row with nothing else clauses, which would make it where it returns our critical, wounded, or healthy condition. And for our middle range, we would have to add an and check as well, saying that our value is greater than 10 and less than 75. But we can also just nest our if statements. For that matter, we can actually nest our code blocks as well, though it's important to note that if we're nesting our code blocks, CSB evaluates it from the innermost first. So as you can see, if our current HP is less than 10, then we're in critical condition. Else, if it's less than 75, since we already know it's greater than 10, we're just wounded. And if that isn't true, we must be greater than 75 HP and therefore be healthy. And that is a lot easier than writing out 100 switch case statements. Finally, I'm going to introduce just a little bit of JavaScript at the end of this episode just to show how it's done. I'm not really going to get too far into how to actually use JavaScript since a lot of that's going to be outside the scope of this tutorial, but I just want to show you that it is possible and how to do it. So let's go ahead and open our second TBD field, and let's say I wanted to do something with just raw JavaScript in this label. So to access the full potential of JavaScript within Custom System Builder, rather than just predefined functions, we're going to use a different kind of code block. So rather than using the $sign curly brace, we're actually going to use a %sign curly brace. So this is actually going to be our JavaScript code block. And I'm going to go ahead and just use this to check the type of data that our number field returns. So we do that by telling JavaScript to return the type of, and then our input, which unfortunately our components are a little bit buried. So we're going to go through the entities data, the system objects, the property objects, which is abbreviated to props, and then our component key. So if we save this and reload our actor, we'll notice that our number fields are actually a string. Yeah, and that's important to keep in mind when you are working with number fields in JavaScript. So I'll go ahead and give you one last concept that you can spend a little bit of time digging through just to get a better idea of how to understand how data is actually stored within Custom System Builder. So if I go ahead and open my console by pressing F12, I'm going to go ahead and enter the following command. From UUID sync, and then in parentheses and quotes, I'm going to put my actor's UUID, which we get by clicking this little button here at the top of our actor, .system.props outside of our parenthesis. And so that's going to just start us down in our system props folder. And as you can see, we can view all the data within our actor's system props file and actually explore a bit of the structure of it and get an understanding of what's going on behind the scenes as far as JavaScript is concerned. So I'd recommend playing around both with how to reference things in the different functions on the wiki, as well as the data structure within the console. And just getting very familiar with everything kind of going on here, since I can explain it to you, but unfortunately this is something that you're just going to have to get your hands on to actually really commit it to memory. In our next episode, I'm going to be showing you a bit about where and how I'm using the formulas, but I'm largely going to be time-lapsing through the data entry since that's just going to be boring and repetitive and just going over what we just covered just time and time and again. So if there's demand for an episode where we go through every function available, not only on the wiki, but through Math.js as well, let me know in the comments. But for now, as always, thank you for watching. Don't forget to like, comment, and subscribe. And I'm looking forward to seeing you in the next episode.